Today we will be adding and subtracting rational expressions. First thing you might ask yourself, well, how do we add or subtract rational expressions? Well, we just do it just like with normal fractions, okay? Let's take a look at a simple example. Notice we have 5, 6 plus 7 over 15. Remember, the first thing we did back in the day is we identified what our lowest common denominator is. So the lowest common denominator of 6 and 15, hopefully you recognize to be 30. And to turn that 6 into 30, we have to multiply both the numerator and the denominator by 5. To turn that 15 into a 30, we have to multiply the numerator and denominator by 2. So the first fraction becomes 25 over 30. The second fraction becomes, 14 over 30. If back in the day, all you did from there is add the numerators. I want you to get into a habit of writing it as one giant fraction. And we only add the numerator. We do not add the denominator. That is a very common mistake that I will see. And this ends up being 39 over 30. And then we asked ourselves, are we finished? Well, meaning, are we reduced to lowest terms? And the answer to that is no, because both 39 and 30 are divisible by 3. 13 over 10. The end. If we look at a simple algebraic example, the first thing I would do is I would factor the denominators. Okay? That way we're able to see what our common denominator could potentially be. Okay, so now we need to identify our lowest common denominator. So if we look in the first fraction, there's an x plus 1 and there's also 1 in the second fraction. So we need to include that in the lowest common denominator. We also have to include the x minus 1 because it is not represented. Remember, you have to have your numerators represented in your lowest common denominator. Okay? So the next thing we're going to do is we're going to identify how do I turn that first denominator, x over x plus 1, into x plus 1, x minus 1. Well, we have to multiply both numerator and denominator by x minus 1. For the second denominator, how do we turn that x plus 1, x minus 1 into the lowest common denominator? Well, we're fortunate for here, it's already okay. Now, just like before, I want you to get into a habit of writing it as one fraction. So we'll have x times x minus 1 plus 3 over x plus 1, x minus 1. Okay, now all that's left for us to do is to simplify the numerator. So we'll distribute, right? So we're going to distribute these guys. So x squared minus x plus 3 over x plus 1, x minus 1. Okay, and unfortunately we can't reduce that because x squared minus x plus 3 does not factor. The last thing for us to do is to do the domain. Remember, anything in the denominator, if I set that expression equal to 0, I cannot do. You can't divide by a 0. So we have to also specify that x cannot be 1 or negative 1, or plus or minus 1 would work too. All that's left is to do some examples. Okay, so we're going to add each rational expression and we're going to state any restriction on the variables. Let's look at the first. So in the first example, notice we don't have to do any factoring. We just have to identify the lowest common denominator of 10, 15, and 25. Hopefully you recognize that the lowest common denominator is 150. Well, what are you going to multiply 10 by to get 150? Well, hopefully you recognize, oh, you're going to multiply that by 15. What are you going to multiply 15 by to get 150? And hopefully you're like, oh, times 10. And think of how many quarters are in $1.50. Well, you're going to multiply that third fraction by 6. Okay, and if we notice, once we simplify, we have 15x squared over 150 plus 20x over 150 minus 6 over 150. And then all that's left for us to do is to write it as one fraction. And because we can't combine any like terms, that's it. And notice we do not have x in the denominator of a fraction, so in this example, we do not have any restrictions. If we look at the other example, the first thing I'm going to do is I'm going to factor those denominators. And x squared minus 3x plus 2, factors of 2 that add to give you negative 3 are x minus 1 and x minus 2. The next step is to identify what the common denominator is. So our lowest common denominator, obviously we need an x minus 1, right? Because it is, notice, here and here, so we need it in our LCD. And we also need an x minus 2 because we still have an x minus 2 here. And we need to have everything in the denominators represented in the common denominator. Okay, so now we're going to ask ourselves, how do I turn that first denominator into our lowest common denominator? And hopefully you recognize you multiply both numerator and denominator by x minus 2 because it is missing on the bottom. Now we're going to ask ourselves, in that second fraction in the denominator, how do we turn that into the lowest common denominator, x minus 1, x minus 2? Well, hopefully you recognize it's going to remain unchanged because both pieces of the common denominator are already there. Okay, now if it were me, I would write it as one fraction next. Now, if you want to distribute in the same step, that is completely fine as well. X squared minus 2x plus 2x minus 1 all over x plus 1, x minus 1. Okay, all that's left for us to do is to simplify the numerator. Notice we'll have x squared. Our two x's, however, cancel out. So x squared minus 1 over x plus 1. Oh my goodness. You guys did not catch my mistake. There should be a minus 2. X plus 1 and x minus 2. Now we're going to ask ourselves, is that fraction reduced to lowest terms? And unfortunately, it is not. We know x squared minus 1 will factor to x plus 1, x minus 1. And our denominator is x plus 1, x minus 2. And notice x plus 1's cancel. So our final answer, x minus 1 over x minus 2. And then we have to state our domain. X cannot be. So notice in our common denominator, x cannot be 1 or 2. And that's it. I want you to take a few minutes and try both example U-tries. Okay, so hopefully for letter A, you did come up with the final answer of x plus 2 over x, where x is not 0 or 1. And for letter B, x squared plus 4x plus 1 over x minus 1, x plus 2, where x cannot be 1 and negative 2. So now we're ready to talk about subtraction. Well, how do we subtract rational expressions? Exactly the same way as with fractions. It's really no different. So if we look at a simple example like 5/8 minus 3/10, remember what we did before with addition. We're going to identify the lowest common denominator. And the lowest common denominator of 8 and 10 is 40. So then back in the day, we asked ourselves, how do we turn that 8 into 40? And remember, you're going to multiply both numerator and denominator by 5. And to turn 10 into 40, you multiply both numerator and denominator by 4. Okay, so the first fraction becomes 25 over 40. The second fraction becomes 12 over 40. Okay, now I would write it as one fraction 25 minus 12 over 40, and we know that to be 13 over 40. And then just like with addition, we're going to ask ourselves, is that reduced to lowest terms? In this case, it is yes. Now let's look at another example. So just like with addition, the first thing we'll do is we will want to make sure our denominators are factored. Okay, and then remember, we're going to identify our lowest common denominator, just like with addition, and we know we need an x minus 1 and an x plus 1. So the next step becomes, how do you turn that 2 over x minus 1 so the denominator looks like the common denominator? And hopefully you recognize that you have to multiply both top and bottom by x plus 1. The second fraction remains unchanged because the common denominator is already represented in the lowest common denominator. From this step, you can distribute in the same step if you would like to, and write as one fraction. So 2x plus 2 minus 1 over x minus 1, x plus 1, which gives us a final answer of 2x plus 1 over x minus 1, x plus 1. And remember to state your domain. We look at our factored form. Typically, you can look at the lowest common denominator. So we have positive 1 and negative 1. And that's it. So just like with before, we're just going to look at some more examples, and we're going to practice subtracting this time. So in this first example, again, you want to make sure you have your denominators factored. The greatest common denominator of x squared and 2x is x. Okay, and now we're going to identify our lowest common denominator. So our lowest common denominator, notice we need a 2 and an x minus 2. So what are we going to multiply that first fraction by so that the denominator matches the common denominator? And hopefully you recognize that you're really only going to multiply numerator and denominator by 2. And that second fraction, you are going to multiply both numerator and denominator by hopefully you recognize x. Okay, now this is where I see the biggest mistake every year. It's fine to go ahead and distribute the 2 and as you write as one fraction, that is okay. Where I see people is they neglect to distribute the negative to both terms in the back expression because they're subtracting. You have to distribute that negative. If you do not distribute the negative, you're going to be frustrated because you will not come up with the correct answer. Okay, so all we have left to do is to combine our like terms. So let's see, we'll have negative x squared. Notice the two x's cancel out. And if you notice that x squared and 4, that could potentially be the difference of squares. We just have to factor out a negative first. Okay, so notice that we can factor x squared minus 4 to x plus 2, x minus 2. And notice what drops down, the x minus 2's. So our final answer, negative parentheses, x plus 2, close, over 2x. And x cannot be 0 and 2. That's it. Okay, so notice in B, we don't have to do any factoring. All we have to do is to do the lowest common denominator. And the lowest common denominator between all three terms, notice 5 and 15, the common denominator would be 15, and x cubed and x squared would be x cubed. So 15x cubed is our common denominator. Now what are you going to multiply the first fraction by so the denominator matches the LCD? And hopefully you recognize you're just going to multiply by 15. For the middle fraction, to turn 5x squared into 15x cubed, you're going to multiply numerator and denominator by 3x. Okay, and for the 15 in the third fraction, to turn that into 15x cubed, you'll multiply top and bottom by x cubed. Okay, now, just like I told you in the previous example, the number one mistake I see with subtraction is distributing the negative, and especially this one here, tricky. This one is usually okay, because students recognize that means subtract, but that middle one is always missed. Let's see, 15 times 5, 75. 15 times 9, 135. Negative 6x squared, that's a negative sign, plus 9x minus 4x cubed over 15x cubed. Okay, so all we're going to do next is we're going to combine like terms, so negative 4x cubed, x squared is negative 6x squared. If we add 75x with 9x, 84x, and then we have plus 135. And our denominator remains the same, x cannot be 0. Okay, so now we're ready to do example C. And notice we're going to factor our denominators. Factors of 24 that add to give you positive 2 would be z plus 6 and z minus 4. In our other fraction, factors of 4 that give you negative 3 would be z minus 4 and z plus 1. And our lowest common denominator this time is z plus 6, z minus 4, and z plus 1. Okay, so notice that a lot of this, we have our z plus 6, we have our z minus 4, and we have our z plus 1. All of our denominators are represented, so we're ready to move to the next step. To turn our first denominator into the common denominator, we'll multiply numerator and denominator by z plus 1. The second fraction, you'll multiply both numerator and denominator by z plus 6. Okay, so from there, remember the big mistake is distributing this negative through the binomial. This one is usually okay. So the first fraction becomes z squared plus z, and then we'll have minus 2z minus 12. And our denominator remains the same, z plus 6, z minus 4, z plus 1. And we combine like terms in the numerator, z squared minus z minus 12 over our denominator. And then we have to ask ourselves, is that reduced to lowest terms? Well, it turns out we can actually factor that numerator. It does factor to z minus 4, z plus 3. And our denominator remains the same. Now, what do we notice here? Hopefully you recognize that there's a z minus 4 in top and bottom. So our final answer is z plus 3 over z plus 6 times z plus 1. And look at your common denominator to get your domain. Z cannot be -6, 4, and -1. And that's it. In word of warning, there will be one on your formative in which it does reduce down like this one. Last but not least, I want you to try the 3 remaining example U-tries on your own. Go. Okay, so hopefully for A, you had something along the lines as x minus 2 over x minus 1, where x cannot be 1 or 2. For B, you should get a final answer of 8 over x minus 6. That one is tricky because students fail to recognize that x minus 6 and 6 minus x are really similar. You can factor out a -1, and then it actually turns out to be x minus 6, and then double negatives change to plus. And then for C, hopefully you recognize n squared minus 3 over n minus 2, where n cannot be 0. And that's it. You're ready for practice. The end.